Okay, let's go. So this time it's about frontend. So program of the day, we're going to talk about the asset canister, which is enabling you to host websites on the IC. Internet identity that you have probably already used by now, but I will explain a bit more how it works, how it has been designed, and how you can use it. We'll talk about certification, agent, to communicate with the IC, boundary nodes, and a few more things. So the IC enables something that is very revolutionary for a blockchain because you can actually store your websites directly on the internet computer. And so, as you can see, you use what's called the asset canister, which is essentially just a normal canister. You create your front end. It's traditional front-end development. So you can use Svelte, React, Vue, any framework that you want. Then you compile that to a bundle, and then you upload your files inside the canister. So you have your HTML, your CSS, and JavaScript, traditional front end. And then whenever you're browsing on the internet and you're on the internet computer website, you simply load the assets from the canister. So essentially, the canister is able to answer HTTP requests and just return you the assets. So then everything happens on your side, so on your browser. So this is pretty cool. And so the asset canister, what is it exactly? It's as I said, it's just like any other canister, but the code for it has been written. There is a public repo. You can check it. I think it's written in Rust. And this canister is bundled with DFX. So when you install DFX, you also have a copy of this canister that is downloaded for you. And when you go to your dfx.json, so I've taken a screenshot here with frontend. When you select the type frontend in dfx.json, it will automatically assign the asset canister. So the asset canister is deployed for you, and then the assets are uploaded for you. So you need to specify the type of the canister asset, and you need to specify the source. The source is essentially where you build your frontend. And so let's do a quick demo of the asset canister. So it's not this one, it's the VS Code is here. So I have already prepared something, and I think I have my replica that is stopped. So I'll start a new one. I'll stop this one and start a new one. So as I said, here we have the front end, and I'm just going to deploy it. So here we go. So this is my front-end canister. The ID is here. As you can see, it's already automatically building and deploying the backend as well, because we have listed the backend as a dependency of the frontend. So essentially, every time the frontend is deployed, the backend is also deployed. And so we are installing the code for it. So the code is coming from DFX. As I said, there is a WASM already ready for you. And that's the interesting part. So once your asset canister is deployed and ready, then you are fetching all the assets inside. So as you can see, this is coming from my dist folder, which is here. And the dist folder is generated when I build my frontend. And all the assets that you see here, so we can see ASO logo, the index.css, the index.css, the JavaScript files, all of this is being uploaded with the index.html. And as you can see, the assets also are uploaded with a hash. So you can see the hash here. This is in order to certify the asset. So I will explain that later, but essentially it gives you give you confidence that the asset that you are uploading are the assets that you have. Once it's done, we have the deployed canister and we can check it. So I will use the candid interface and check the. So if we go directly to the front end, if we use this command, so localhost 4943 canister ID, this is the front end. It looks like this, but we can also check what the candid UI is. So essentially, what is the interface of our front-end canister? If we go there, we see something different. So we see all the methods. If you were to look at the code of the asset canister, this is what you will see. So as you can see, you can commit batch. So batch are like, batch of assets. And then you can create assets, create chunk for the assets, because you cannot upload. If you have large files, you need to create chunks. You can delete assets, get assets, and so on. And the most important, I would say, method is this one. So HTTP request, which is the one that is being answered when we do the traditional browsing and we go on the website. So it just answers this with this method. Okay. Any question on the asset canister? I'll answer about the backend later. And can you deploy 2 separate canisters and link them? So yeah, you can have one front-end canister, so your asset canister, and you can talk to any other canister on the IC. So you can have multiple backends. Yeah, that would work. So yeah, as I said, all of this is coming from the FX automatically. This is whenever we set the type here. So we set type asset, and so DFX automatically know that, and we'll just put the canister, like put the WASM, the correct WASM for us. So you don't have to worry about that. Okay, let's go back to the presentation. So actually, I said that canisters can answer HTTP request, which is true if we simplify, but in reality, it's a bit more involved than that. You have something called boundary nodes. So you can see the drawing here, and you essentially have 2 layers of nodes within the IC. So you have the consensus nodes. That's the one we've been talking about. Those are the one where the canisters are living, where the files are stored, and so on. And you have the consensus nodes, which essentially is like an external layer to the IC, and it acts as a protection, and it's also what enables us to communicate with the IC. As a user, when you're browsing with your computer, you will never directly talk to the consensus nodes. That's to prevent, for example, attacks. So if you were to communicate with the consensus node, you could, for example, do like a DDoS attack and just crash a subnet or something like this. So this is to avoid that. And so they have a lot of utility. They have a lot of utilities, but I've listed some of them. They do rate limiting. So essentially, if they check that you have the same IP address, they will prevent you from spamming the network. They do caching as well, so that the content is delivered faster, and a few other things. For example, they enable you to do SEO. Right now, as of today, so we are August 2023, the boundary nodes are probably the most centralized piece of the network, because all of them are run by Dfinity and Dfinity only. However, there is a program which is coming, I think, at the end of the year or early 2024, where everyone will be able to run a boundary node and also get rewarded for that. And the requirements for the boundary nodes are very light. So essentially, you don't need the computation power that you need for the consensus node. You need way less. So this is something you can do with like your personal computer, or even maybe your Raspberry Pi, or just a basic server. So I think that's something that's going to be very, very cool, because we'll see more people getting involved with the network. One last thing, when you do HTTP requests, it goes directly to a boundary node, the one that is closer to you. Depends on where you're living in the world, but there is probably some of those nodes around your country. And then these nodes translate your HTTP request to what's called the IC API, which is essentially an internal way of communicating with the IC. A bit more about boundary nodes. They also serve the service worker, which is an important piece. So whenever you go for the first time on a website, you will see this this loading screen. So loading resources, it says blockchain cryptography will make this domain more secure. What does it mean? Simply means that you are being loaded the service worker. So it's a JavaScript file essentially that is stored in the boundary nodes. Once you have this file, the service worker is automatically going to load the assets, so load the website for you. But it's also doing one thing, which is verifying the integrity of the assets. So I said before, the assets are certified. So essentially the canister sign a hash of the assets. And whenever you receive the assets, the service worker is going to compare whatever the canister is saying with whatever you have locally. So this is to prevent malicious assets to being loaded, essentially. Essentially, that means that if you have a website, you can fully trust that this is what has been uploaded to the IC. So yeah, it's super cool. It's also doing other things like translating the requests to IC API as well. But essentially, the most important part is this certification. And we can actually see that there are two types of URL for the IC. So the first one is ICP0.io. And let's say we go to, let's say we're looking for a canister. So do we have some kind of websites? I don't know. This one, .icp0.io. Okay, so this is not a website, but anyway, I just wanted to say there is another way to access ICP addresses, which is with .row.icp0.io. And the .row is essentially the same, but there is no certification. So it's usually faster, and you can also see that, well, it doesn't work for this one, but I don't have an example right now. But yeah, essentially it's just skipping the certification. So sometimes you will see those kinds of address with the .row. Okay. Now let's talk about internet identity. So internet identity is a replacement for username and passwords. So in Web2, when you go to Facebook or Reddit or YouTube, you have an account and you have a username, you have a password. Sometimes you also have like second factor authentication, but essentially you have username and password. And it's not the best way to authenticate users. First thing is you have to remember all your passwords. So you can use password management services, but you still have to remember something. And also there is a problem, which is whenever a database is leaked, so if the website is being hacked or something malicious happen, because the web, like your password is being stored somewhere. So if the creator of the website or the manager of the website are following the best practices, they are going to hash your password. So it's not going to be clear what it is, but there is still a way for hackers to go through the list and essentially guess what can be your password. It's just a matter of computation resource. It takes time and it takes money, but it's something that's possible. The problem is that you have to, like the server has to know your password to give you the access because it needs to verify that's the correct one. There is an alternative which is also coming, which is login with big tech. You've probably you're using that at the moment, like login with Google or login with Apple or Facebook. And it's great for having less passwords around, but it's also a huge problem because you're essentially giving a lot of information to one specific company, and they could, in theory, access all the accounts that you're creating. So if you're creating an account on a website with a using Google login, in theory, Google could use your access and just do things for you. So it's not the best, and it's probably a very centralized solution at the moment. So internet identity is there to replace that. It's a built-in system, so it's very usable for developers and also for users. An internet identity is just a canister deployed on the internet computer. So the first time you use it, you will see that you have to create what's called an anchor, which is a number. And then you can add devices. You can add your phone. You can add your computer. Maybe you have another phone. You can add multiple devices. You can also add recovery methods. And essentially, what's happening is that you have a public key and a private key. So if you're not familiar with public key, private key, please let me know. But I guess that's something that you probably all know. And so it's a framework which is called Web Authentication, which is a pretty standard framework now. It's not only Web3, it's also compatible with Web2. Essentially, you have your private key, which is stored on your device. So let's say this iPhone, for example, there is a chip inside, and there is a private key that is stored. And whenever I want to log into something, I will just use the private key. So the private key will sign a message. This is what happens when you see the, the Face ID or the Touch ID. It's essentially signing a request. And then the server on the other side can verify that the signature is yours because it knows your public key. So the problem with that is that each device is going to have a separate private and separate public key. So if you have multiple devices, in theory, you should have multiple identities, but it's not very practical. And that's what internet identity is solving. You can add multiple devices, and you can still log in with the same profile. I can log in from Discover, from my iPhone or from my computer, and I still have the same profile. So let's dive into it. When you send a message on the IC, the message looks a bit like this. So you have the name, the public key of the sender. You have the canister ID that you're targeting, the function that you're targeting, some arguments if you are also adding arguments to the function, and there is a signature. So this is very different from Web2, because in Web2, once you log into a service, you don't sign all requests. Like you can just send like a request to a server and you don't have to sign all of them. On the IC, you have to sign every message. So every message that you send is going to be signed. And your principal is essentially hash of your public key. So you can see here, I have coded this little example. I can show you later as well. It's a who am I function. So it's just returning the principal of the person that is calling this function. And so I have an identity and I have a principal associated with this identity. Okay, one other topic I wanted to touch on is delegations. So the problem, well, not the problem, but you can create something called delegations. So let's say you have a public key. You can use you can assign power to you can assign powers to other keys. So you have your public key, the pink one, for example, but you also have other devices, and the other devices is the yellow one, and you have another device and it's the blue one. And so you want to be able to sign with the same identity using the two devices that you have. And so what you can do is you can use one of your first device. So let's say the pink one, you create a delegation on the yellow one. And so you can specify how long. It can be very, very long or very, very short. And so now whenever you're using the yellow one, you also have the power that are assigned to the pink one. And you can repeat that. So you can also do a delegation from the yellow one to the blue one. This is exactly what you're doing when you're adding devices to internet identity. Essentially, you're creating delegations so that the key that is in my phone can have the powers of the key that is in my computer, and so on. So you can have the same profile and you can connect like this. So here is in details exactly what happened when you log in with internet identity. So step one, let's say I go to Discover, HTTP discover.1. I go to the canister corresponding to the application. It loads the front end. Then I see on the front end, there is a logging button. So I click on it. It's going to create a session key pair. So a session key pair is a key pair, like public key, private key, but that is very, very temporary. So it's just creating one. And then it's redirecting me to internet identity. So you see the window pops up and then you're prompted to log in. And when you log in, it's going to ask you for Touch ID or Face ID or some kind of verification. This is where the device that you are on is signing the request. And it's creating a delegation. Then it's sending that to the internet identity, the canister. It's verifying that the device is correct and the signature is correct. Hopefully, you have already registered this device with your identity. So everything is working correctly. And if it's correct, then internet identity is going to create a delegation it's going to sign a delegation on the session key pair. Then it returns that, it's stored in your browser, and you can use the delegation to log in, to interact with Discover for, it could be for 30 minutes or 2 hours. It depends on how long the time has been set by the developer. And the good thing about that is that in the web authentication framework, so traditionally you should be prompted for confirmation every time you sign a message. And so that would be very annoying to every time you use something to have to verify and say, yes, I want to sign that. When you have your delegation, you don't have to sign every time. So you can do multiple actions. You can send multiple messages to the IC, and it's still being signed on your behalf, but you don't have to approve that. It's automatically approved for you. And if your browser get leaked or something bad happen, you don't lose your identity. You just maybe someone get access to your session key pair and they can do a few things on Discover, but they cannot really get your internet identity because your key is never leaving your devices. So it's pretty strong framework for login. Pretty cool, and also pretty simple to use as a developer and as a user. One last thing about internet identity, it also prevents tracking across applications. So let's say we have application A. So in this case, it's Discover. We have application B, which is also Discover. It shouldn't be like this. Let's say it's another application. When you go to Discover, you're going to have a principal which corresponds to your identity. It's not the same as the principal on the other application. So essentially, if you look at the Discover user base and you see a principal for you, there is no way to track you on another application, except if you have explicitly linked those principles. Like there are ways to do that, but otherwise, this is to respect privacy and this is to prevent tracking across applications. So it's pretty cool for you as a user because it's in contrast with most like login with big tech, which can track you across all your application and all your internet usage. The problem with that is that it's also hard for developer to build application that essentially request information. Let's say you want to create an application where you need to know if someone is registered on Discover and also on OpenChat, and you want to do like a mission or something, and you want to know that. So you have to build essentially a system to in-house system to do that, because by default, internet identity will not give you this information. Okay, so I wanted to do some live coding to finish this lecture. So let's open back the projects. I'm using the Svelte starter. So this is Vite, Svelte, and Hazel. This is the one that you have on the GitHub repository. And I'll follow the instructions about integrating with internet identity. So here I've created the guide for you, how to integrate with internet identity. I have diffx 0.14.3 beta 0. So I'll just add this. Okay. Then deploy it. Making sure that I have the correct packages. So I can check that in my package.json. I have already those packages. I have hot client and identity. And so now I should be able to use this. So this is the login function. If I go to my app.svelte, I have, let's say counter. So here I have a button. On click just says that whenever I click this function is called. So I will change that from increment to login. So this is the login function. I'll use this. I need to import hot clients. I can also remove that. Import hot clients. Okay. And once this is done, I will console.log hot client. I will probably get the identity first. So identity is hot client.get identity, and then I will check my identity. Click here to login. And now I'm doing the fx deploy. Yeah. So there was one question about how are the session key pair terminated. Yes, it's about just the time. So this is where you specify the max time to live. And also there is a possibility that if you delete your local storage, so the keys are stored in the local storage of your browser, you could lose the session key pair. Okay. Now I'm starting the development server. And so I can click here to login. I create a new one. And in the console, I should see my identity. So maybe we can also say, oh, I made a mistake because here it's on success. This is going to be called. So we want to be inside of this. I want to put the code here. And after that, we want to maybe get principal. So principal is going to be identity.get principal to string. Let's see what happened. Oops. So this is my principal from this application. So this one. Now I want to show you something. So if I create two backends, let's say I rename these to canisters, and I have backend 1, backend 2, index.ts here as well. So I'm creating two backend canisters to see if the principal corresponds. Let's say backend 1 and backend 2. So this time it's located inside canisters. backend 1 and same. Oops, my bad. I think it should be good like this. Isol canister backend 2, backend 2, that was let's see. Oh, so it's the same backend code. This is just a who am I function that returns the caller. Okay. So there seems to be an issue with the canisters backend 2, backend 2. Very strange. What's happening? So it doesn't seem to find this file, but this file is there. I'm taking a look at the repo. Oh, okay. I don't need to put that. Yeah. I could also have copied just the path. Anyway, I think it's working now. Okay. So we have two backends, and I will try to log into the two backends. So create an actor. So let's see how we build our actor. I think it's described here. So create actor like this. Need to import actor and HTTP agent. We also need to import ideal factory from the declaration. So it's from yeah, I can zoom a bit just like this. So wait, where is this? Like, is this one, right? Ideal factory. So I can also just do, I think, like this. So I'm just using the index.js to export the backend one. So we already have the create actor that is done for us. So we don't really need this. And now I'm gonna get constant principal one is backend one. Who am I? And principal two is backend two, and then we'll get that to text or to string. It's the same. What's happening here? Super annoying. Oh, of course. Okay. Okay, we'll do like this. Let's try it out. We don't really need to redeploy. We're good. So if we log in here, we have the same, well, we are using just one identity, so impossible to convert undefined to principal from let's just remove that for the time being and see what happens. Interesting. I have no idea what's happening here. So a really lot of strange things happening. Let's take some time to fix that. So why can't I just import the ideal factory creation? Uh, okay. Is it just about the path? No. Why is that? I really don't get it. If someone get it in the comments, please let me know. But like, I mean, the file is just here and I can see that we export this. So why can't I just import it here? Something messed up with the config maybe. And I can import the backend like this, but then it doesn't work. Oh, wait, is it? Mm, yeah, the name is correct. Can I at least import it from the index? Maybe. Okay, yeah, I can do that, but Intel factory 1, Intel factory 2. So yeah, instead of importing directly from here, I'm importing it from here. But okay, let's do like this. Doesn't really, it's not very clear why it doesn't work, but let's move on. So I'll create an agent with my identity. So new HTTP agent with my identity, and I'll pass it to create authenticated actor. So constant actor 1 is gonna be the canister ideal factory 1, and the canister ID, let's just go with canister ID backend 1 as string. And actor 2 is gonna be this as string. Now let's do what I wanted to do from the get-go. So this is, and now 1 principal 2, 2 string. Okay. Thank you, TypeScript. So let's say what I'm doing. Okay. What? It doesn't have access to the types. Oh, this is so annoying. I think there is a problem with the config of this. Okay. Let's try. Oops. That's not what I wanted. Okay, same issue. Impossible to convert undefined to principal. No, it's not a problem of which backend to call. It's knowing here which backend to call. It's just about I don't know exactly what's happening, to be honest. It's pretty strange. I had it working, but now it's messed up. I don't know. Did someone encounter this, like this error before? Yeah. Sometimes. Okay, let's see. So this time I'll not use the development server. I will just do it with the front-end canister directly. So the front-end canister is this one. Okay. Ah, yeah. I need to create a new one. Okay. So it's not showing what was supposed to happen. That's pretty funny, but at least it's working. But it's the same principle, which is not supposed to be the case. So we have a new thing to fix now. Well, actually, I think it's normal. I think I understand what's happening. So let's go to the internet identity repo. Internet identity GitHub. So those are the specs, and this is where we see how our principle is defined. I think it's user ID. Yeah. Okay, yeah. So I did a little mistake, which is it's not about the backend that you're calling, it's about the front end you're calling from. So when I say you have multiple principal, it's the same principle if you have the same host. So essentially, when you go here, you see how the user ID is defined. So it's you take the hash, this is SHA-224 of your public key. You add some kind of seed, which is like some randomness coming from the internet identity canister. So here you have the hash, you have the salt user number, which is your anchor, and you have the front end host. So this is where the front end matters, but not really the backend. It's about where you're connecting from. So maybe I can do, well, actually it's pretty simple to show, I think, if we do just from this place, and if we do, so npm run start. Oops. Oops. Yep. Okay. So I'll be able to show you what I wanted to show you. This is localhost. So this is my development server. This is the canister frontend directly. And you can see I'm logging with the same anchor. So this is 10,000. And here my principal is this one, 5U, 3PR, and so on. And here it's another one. Yeah, it's X5CGH and so on. And yeah, this comes from here, which is where we define our principal, and it depends on the front-end host. So yeah, essentially, if you're connecting from discover.one or oc.app or any other front-ends, you will have a different principal. Yeah, this is what I wanted to show. It doesn't depend on the backend. Sorry for the confusion right here. think we're done. This is the hour. So yeah, thanks everyone for joining. The next session is in 2 hours with Jordan, and it will be about stable memory. It's pretty important, so make sure to join. Actually, it's just in 1 hour. It's very, very important. We are going to talk about how to upgrade, and also I think I will dive in details into the different types of memory of a canister, the heap, the stable memory, the stable structures, and so on. So see you there. Good luck, everyone. Bye.